Hey, so let's actually use what we learned in the last video to actually solve some differential equations today. So let's just let's start off with this equation right here. Y dy by dx equals negative x. And we're given a condition that says y of 4 is equal to negative 3. So you'll see how that condition comes into play afterwards. So first thing we ask ourselves, is the equation separable, right? So let's isolate for dy by dx, and we get negative x over y. Remember, a separable equation has a form dy by dx is equal to g of x times h of y, meaning you can get x's, you can factor all the x's and factor all the y's. So can we do that with this equation? Yes, we can, because we can get negative x over here, and what are we left with? We're left with 1 over y. So this is our g of x, so this is our h of y. So separable. Once we know that, we can use that method we learned in the last video. So if you know a differential equation is separable, you know its solution is of the form p of y dy integral of that time equals g of x dx integral of that. So remember, p of y is 1 over h of y. So let's just plug everything in. P of y is going to be y, because h of y is 1 over y, so p of y is going to be y. Y dy is equal to negative x dx. Let me just continue on this side. So it's pretty simple integration. We're just going to get a y squared over 2 plus c1 is equal to negative x squared over 2 plus c2. Now, with the constants, you can just make them into one super constant, right? I'm just going to write y squared plus over 2 equals negative x squared over 2 plus c. So that's going to be your super constant. You don't have to label it. It's just the sum of those two. So normally when you do a differential equation, you don't actually solve for C1, solve for C2. You just combine it into one big C, okay, which we're going to solve for right now. So that's where the actual initial condition comes into play. So over here at the top, we had y of 4 is equal to negative 3. So knowing that, we can actually solve for C. So y of 4 equals negative 3. So y is going to be negative 3. So we get 9 over 2 is equal to negative 16 over 2 plus C. So 9 over 2 is 4.5 plus 8 equals C. And that gives us 12.5 is equal to C. So our final solution is y squared over 2 plus x squared over 2 equals 12.5. Correct? Now I can factor out a 2 over here from this side, so I can take that 2 to the other side. So we get y squared plus x squared equals 25. Now, does this equation look familiar to you guys? This is actually an equation of a circle, because remember, equation of a circle in general, circle equation is x squared plus y squared is equal to r squared, right? So this r squared over here is actually 25. This differential equation, what you just solved for, actually represents a circle of radius 5. Let me just draw this out. And now we could actually go back and look at this and ask ourselves, does the differential equation make sense? Like, does it describe this function, right? So what was the original differential equation? It was dy by dx equals negative x over y. Does this correspond to this function? Well, let's see. Let's look at this point. Okay, what is this point? It's 5 and 0, right? What's our slope over here? Our slope is just if you draw a tangent to that circle over there, it's going to be a straight vertical line. So what does that mean? Our slope is infinite. And is the differential equation telling us that? if we plug in 5 over 0 into this differential equation right here, what are we going to get? We're going to get negative 5 over 0 for this case. Does that describe a vertical line? Yes, it does, because it's telling us the slope over here, slope at 5 and 0 is infinite. Okay, if it's a vertical line, your slope is infinite. So this point makes sense. So let's try this other point. Let's look at this point right here. What is this? 0 and 5. What's the slope at 0 and 5? Slope at 0 and 5, if you draw a tangent line over here, that tangent is flat. So that means there's no slope. So if we plug in 0 and 5 into negative x over y, what do we get? We get 0 over 5, right? So this tells us, oh, slope at this point, 0 and 5, is going to be 0, right? That's what this differential equation is telling us. Okay, so let's just do one more point, just to convince ourselves that our solution satisfies our differential equation. Let's choose this point right here. Okay, it's not obvious what the coordinates are, so we actually got to figure out the coordinates. So if I were to draw a straight line from here to this point, that's going to have a length of 5, because again, it's a circle with a radius of 5. So we're going to have a small little triangle right here. So we got to find this x, got to find this y. This angle is going to be 45 degrees, okay, because x and y are equal. Like this length is equal to that length. So 45 degrees, we have this side of 5. So therefore, sine of 45, 5 sine 45 is equal to 5 root 2. That's our y. X is going to be 5 cos 45. That's 5 root 2. Okay. So our coordinate at this point is 5 root 2 and 5 root 2. What does the slope look like at this point? You can see it's actually, it looks like a slope of 1, negative 1, right? And does the differential equation support that? So if you plug in dy by dx, and we get negative 5 over root 2 divided by 5 over root 2, what do we get? We get a negative 1. Okay, so you see how we went from a differential equation, we figured out what the function is, and now we're going backwards to make sure if our differential equation fits our solution, if it describes our solution. Okay, so it's just like a verification check. Last thing I want to discuss in this video is very important. Let me just rewrite the differential equation again. So dy by dx equals negative x over y. So last video I said if you have a case like this, dy by dx times dx, you can't cancel this and this dx and this dx out, because again, they're not variables, okay? You can't treat them like variables. However, I said for this case, this just ends up being dy, that's as a rule. But even though it's not mathematically correct, you could actually treat the dx's and the dy's like variables. You could even like cross multiply with them, bring this to the other side, bring that to the other side. It's not a mathematically legal operation, but it actually ends up giving you the right answer, believe it or not. And that's actually the method they actually teach you in school. They don't teach that, oh, find h of y, find g of x. They actually tell you, hey, take all the y's to one side, take all the x's to the other side. So let me show you that method. So in this other method, you can actually move around the dx's and dy's. So let me take all the y's to one side. So I'm going to get y dy, right? And then I'm going to get negative x dx. This is illegal math, but ends up giving you the right answer. And now you just put the integral sign. And then there you go. This gives you the same answer as the p of y dy method. So I'm leaving this up to you. Whatever you want to use. You want to treat these like variables and just get all the y's on one side and all the x's on the other side, or you can do the method we've been doing, where we identify p of y, we identify g of x, and we just put them into this form. It's up to you. And that's it for this video. Thanks for watching. Hope you learned something. And please like, If you have any comments, make sure you comment and subscribe for more videos too. Thank you.